ka module wa algebra. So chapter 2 ibe khona introduction of linear system or linear equation. We must be able to know the linear system and non-linear equation. Anche un round which is difference between linear system and non-linear system. So let me just take you through that of what the difference between linear system and that non-linear system. For example, if you see this question, let me see here we have the C, and then this is A1, B1, and C1, and then A2 x plus B2 or y is equal to C2. So now this is called a linear system. So it's given in that form. But now, what is non-linear system? Non-linear system is when maybe this is no longer in a linear form. When it's a linear square, and the y when it's a linear square like that. Therefore, this equation is no longer linear. Because that's straight line. This straight line is linear. Y is equal to mx plus c. This is linear. But if I have a that x squared, now this is
parabola.
It's a parabola. Why? It's no longer linear because of the what? Of the square. You see that?
Yeah.
But when you remove this term, you are now going to have a linear.
Yes.
So the square is the one that controls the linearity of the system. So it's the same thing in this one. So that is about the linear equation. So you must be able to distinguish between the linear and the non-linear system. So whenever you see the squares or the cubic, you must know that it's not a linear, but this with x that have exponent 1 and y with exponent 1, then it's a linear. And then the gas elimination, we have done this together. I showed you how you do of the gas. So I believe by now you'll be able to decide. And then the matrices and the matrix operation. So again, I think operation in detail of how we deal with the operations. So operation is about plus, minus, and multiply. So these are the operations of which now I know you can be able to apply them when you have a real number. For example, if we have two numbers, let's say we have number 4 and number 2, we know if we want to add them or we want to use the operation of addition, this when we add them, we're going to get a 6. The operation of subtraction is 4 minus 2, which is going to be 2. Operation of multiplication is going to be 4 multiplied by 2, which will be 8, and then for division, it's going to be 4 divided by 2 equal to 2. So these are the operations of which we apply them in the real now. But now it's different when we apply those operations to the matrices or to the matrix. So it's a bit different, especially when you are dealing with the operation, multiplication and divisions. They are different as compared to when you apply them on the real now. So I've also given this information to you in detail. We also have a video of this. So I think I can send you a video so that you can follow up with regard to the operations. And then yes, the inverse. There are two kinds of inverse which you must know. It's the inverse of 2 by 2 and the inverse of 3 by 3. So I've done the inverse for 3 by 3 with you last time, of which we find the inverse by using this method, which is
called, and the identity.
Yes, you remember that you will get identity, and then what you're going to produce on the other side is gonna be the inverse matrix. So this applies when we're having what? When we're having a 3 by 3.
3 by 3.
Yes. So now again, I've covered the information for when we are dealing with the 2 by 2 matrix, of which I think I must be able to highlight to you of how you deal with the inverse for 2 by 2. So you must be able to know how to get the inverse of 2 by 2. Now, let's say we are given a matrix A, which is given by A, B, C, D. The question is, how do you get the matrix of 2 by, this is 2 by 2. Why do you call it 2 by 2? Because it's having 2 rows and 2 columns. Are we all together?
Yes.
Yes, exactly.
Yes.
Yes, that's why we call it 2 by 2. It's having a size of 2 by 2. Of which, if you want to find the inverse of this, you don't use that method. It's going to be very long for you, even though it works, but you don't use it for 2 by 2. So what you do with the 2 by 2 matrix, you will have to use this formula. It's a formula of which I want to write it. So it's 1 divided by multiplication of the diagonals. So it's AD minus BC into, and then you swap the positions for the diagonal. You're going to have A there, and then you swap this. Here you have D, and then you have A. Then the ones on the 9 diagonal, we put the negative. So it's negative B and then negative C. So this is how you're supposed to attend to the inverse. Can we do an example for finding the inverse of 2 by 2?
All right.
Yeah, so let me do an example so that you see how you find the inverse of 2 by 2. So we are going to have a matrix as an example. Let's say we have a matrix 2, 1, 3, 5, and we want to find the inverse of that. So now we're going to have 1 over, then you multiply the diagonal. So it's going to be 2 multiplied by 5, which is going to give you 10, minus multiplication of the 9 diagonal, which is 3 multiplied by 1, and that will give you 3. And from there, you sharp the positions of the diagonals, which is going to be 5 here, and then the 2 at the bottom. And then on the diagonals, you put the negative. You don't sharp on the 9 diagonals. And there's a 3. So it's going to be 1 over 7 into 5, negative 1, negative 3, 2. And then this will be equal to 5 over 7, negative 1 over 7, negative 3 over 7, and 2 over 7. So therefore, that is the inverse matrix of a 2 by 2. It's how you're supposed to calculate the inverse matrix of a 2 by 2. We use this matrix that we have. Is that clear? Thanks. Thanks. Are you here? Hello? 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 Okay. Raro kumando explain inverse yami. Yep. Da. Hello?
Okay. And now,
all right. Ndakaditauchedza okay, ndakaditauchedza zvine runozvikavhara, but it seems as he left because of the network. But I was just explaining what we have covered, which is everything that we have covered under chapter 1. We are only left with few things under chapter 1. For example, we have covered the linear equation, of which I believe by now you can be able to identify between the linear and the non-linear system. So I explained that to you. And then again, we have covered the gas elimination. We have covered the operations. You must be able to know how to add, subtract, multiply, and divide the matrix. And then we also covered the inverse. So of which inverse we have inverse for 2 by 2, and we also have inverse for 3 by 3. I've covered both procedures for 2 by 2 and also for 3 by 3. So for 2 by 2 is this one that we have here, and then for 3 by 3, you first have to write your notation in this form. It's called row echelon form. So this is how you write your matrix in row echelon form, and then you transform it so that you now have the identity there and the inverse on the other side. So that is how you find the inverse of what? Of 3 by 3. Row terms. Hello. All right. And then from there,
Bondo.
Da.
Atiko wabona kweta ndichobonda baita bachishaba yabashisha pakane zvikoitwa mini bondo.
Oh, okay. Our device is very problematic.
Yeah.
Okay.
Bondo?
Yeah, ndiko todo loka video ri. Ishaita zvoshava.
Okay.
Vakombona zvino.
Atiko wabona zvino total.
Okay. Let me see what the problem.
Yeah, hey, I don't know. This thing, it's
Yeah.
okay. Let me see where you okay.
Yeah, I was explaining.
Okay, 7
the
short.
inverse. Yes, I explained to you.
Okay, then you multiply that with that. Oh, what happened?
So is the inverse of 2 by 2, and then here is the inverse of 3 by 3.
How did we get the but one is an
Meaning?
hello.
Hey, Kubafa.
But one is an
Oh.
Bondo.
Da.
Kasi alangati baboni man.
I'll go into the check what the problem. Abalog out, but don't log in food.
rote or
Whenever component, so I wanna need our log out. Loka screen, but you're gonna who's the problem? Okay, musi vha khou toga ini havhalani ndi vhe ndi khou ṱalutshedza uri hafhanoni ro wana inverse ya 2 by 2 ine ndi ngafhi yo vha vha si khou pfhesesa uri ro i wanisani inverse
ndi hafho ya 5/7 and now 1 minus 1 over 2.
Okay, heyi fraction yoṱhe i khou multiply dzi themo dzoṱhe dzine dza vha nga ngomu. So zwi amba uri 7 multiplied by 5 ya ri 5/7 ya dovha ya multiply
Okay.
Vho Munyai ri roṱhe zwino.
All right.
But okay, now.
Okay, ndo zwi pfa.
Nda khou ḓi ṱalutshedza uri zwa zwino ri hafha kha number 7.
Ndi khou vhona
vha khou mbona?
Yeah, yeah.
No problem. So now today we're going to do the last one for under chapter 1, which is diagonal, triangular, and symmetric matrix. So of which I've covered a bit about this. So you will see it's related with what we have done already. So by now, if we're given a matrix like this, let me give an example by a 3 by 3. So let's say we have 1, 34, 2, 9, 10, 0, 1, 5. So this is a 3 by 3 matrix. Why is a 3 by 3? Because it's having 3 rows and 3 columns. Are we all together? From this, you must be able to point out the diagonals, the values that gives the diagonals. What are the diagonals from this matrix? The values for diagonal from this matrix are what? They're given. We have discussed about this the last time. So what are the values for the diagonal?
9, 5, 1.
Very true. These 3, they are the ones which gives the diagonal. So that's why I said we have done that part already. And then again, for the triangular, we have done something related to that. So triangular, we are talking about when we have zeros at the bottom here or a 0 at the top here. You just choose the zeros you want to find. So if you get the zeros at the bottom, you have the triangular. If you get the zeros at the top, you have the triangle.
Yeah.
Then the last part is the one which I did not cover with you. I'm going to cover with you just now. The symmetric matrix is a very, very important concept, but a very simplest one of which you must understand. So we are going to talk about something which is called transpose. So you must know about what is called the transpose. The transpose is when we are changing the rows to be columns or changing the columns to be the rows. I will just give an example by the matrix that we have here of 1, 3, 4, 2, 9, 10, 0, 1, 5. So now if we are now transposing, we must indicate by the capital letter T, of which you write on top of A. So A is equal to, A transpose is equal to, and now we change the rows to be the columns, of which simply means that this first row is going to be the first column. So we're now going to have 1, 3, 4, and then the second row changes to be the column. So it's going to be 2, 9, 10, and then the last one is going to be 0.
I network could do.
Did you see how we get the transpose of A?
I'm lost. I didn't see anything. I was like offline.
All right.
Network. So where are we now?
Rekowana transpose ya A. Transpose.
The topic number, okay.
1.7.
Oh, okay.
Reapa symmetric. matrices.
Ezo zingoros jumper 1.5 and 1.6.
No, we did not jump these ones. We have done the inverse for 2.
Okay.
Yes. The invertible, I'm going to cover this with you on chapter 2. There's determinant which talks about the invertible.
Okay.
I'll tell you about that in detail. So did you understand about the diagonal, the triangular? Okay, let me just.
Kaba is a camera tanyana. Okay, it's 1, 3, 4, 2, 9, 10.
0, 1, and 5, right?
Yeah.
So from this, the diagonal, this first part of the diagonal is given by 1,
Yeah.
9, and 5.
Yeah.
And then the triangular we are referring to when you are getting the zeros below the diagonal or the zeros above the diagonal. Of which I believe
Okay.
you are now able to get the zeros. So if you get 0 here, the 0 here, and the 0 there, you have the triangular. Or if you don't want to get the 0 below the diagonal, you can get the zeros above the diagonal. The 0 there, 0 here, and the 0 there. So that will give you the triangle.
Then you swipe them or what?
Yes. No, here I'm explaining what is called the symmetric matrix. So let me explain the symmetric matrix, which is the first thing for getting the symmetric is to get what is called the transpose. So transpose is indicated by A to the power capital letter T.
Yeah.
Yeah, so transpose iwana ngochincha the rows zava columns and then the columns zava row. So this is a row. This row is going to change to be what? To be the column, of which simply means that 1, 3, 4, we're going to write it as a column to be 1, 3, 4 down there. And then the second row is going to change to be the column. So it's going to be 2, 9, 10. And then the last one is the third row is going to be the third column, of which is going to be 0, 1, 5. Rerow terms.
Oh, symmetric. Oh, okay. You change your row to column. Okay, we have. Oh, okay.
Let me also find out from Womunyai.
Right.
Bondo.
Da.
Ndikova apa utaizo ezvika screen changa chiva chotoima cho chisonga chistationary chisokumuva basa kumuva mara maipfi ndikuva chikwahamba ndikototecheresa ndikototecheresa mana chisokumuva.
Oh, okay. So zombo nditemeka sho zombi immediately
ngave kuri dini.
I then network.
I think it's the network.
Yeah, the mekasho zombi wasendele recording immediately after uri vakono follow.
Bondo.
Da.
Ndiko request ri vachinsendera recording ndachingato humbelo ri vansendere through ka WhatsApp ka YouTube chifhinga chote icho toto ndive ndikuishumisira data every time and then vansendere ka WhatsApp ndichiviewa zvambori ndiva ndeidownloada once ndichitotoiaccessa ndikaiona at any time with no cost.
Okay. Oh, ndikavakudzana uri vaingaidownloadisani ka YouTube.
Oh, okay.
Ngori YouTube iyakona uri ndisende.
Mara yalasi voisenda ka WhatsApp.
Yeah, ngori yaituku. Khulwane adzitende usenda ka WhatsApp dzapelera. Ndityo ndosina zvipida ngazvipida ende. Ndiva ndoikata lunji nyana. So ka YouTube yatenda uri ndisende yopelera. Lune nditova method une vha ḓo kona uri vha I download ka YouTube.
All right.
Okay. Ndakatachedza uri rikwamba nga symmetric izvi. Zvine symmetric matrix. The very first thing we do is to get the what? The transpose. So I would like to find out from all of you, Uri, did you understand how to get the transpose?
No.
Yeah.
All right. Now, let me also summarize that. Uri, we want to transpose.
Why transport? Yes, I understand. You say we change rows to column.
Yes, exactly.
Yeah.
So now let's get to the business of the day of finding what is called the symmetric matrix. So this is a matrix. Now the matrix is called symmetric if it meets this one condition, a very, very important condition. If the main matrix is now equal to the transpose matrix A, then now this matrix A, we then call it a symmetric matrix. So matrix A will be the symmetric matrix if matrix A which is na matrix A transpose.
Okay.
Of which, now tell me, is this matrix A symmetric matrix or not a symmetric matrix?
It's not a symmetric matrix because they are not equal yet.
They are not equal. Very true. Let me give you an example of the symmetric matrix. Let's say we have A, which is equal to 2, 0, 0, 2. So let's find the transpose of this matrix. What is transpose A? Can it give me transpose A?
2, 0.
It's going to be 2, 0.
And then 0, 2.
0, 2. Is matrix A symmetric or not?
They are symmetric.
It's symmetric because A is equal to A transpose.
Yes.
Very true. That is all about symmetric matrices.
So we're done.
Okay.
Yes, we are done about the symmetric. I'm now going to another important topic which you must take note of. It's on chapter 2.
Okay.
That topic is also going to explain this, which is called the invertibility or invertible matrix.
Okay.
So is what is called the.
So in exam, how do they act like a symmetric like matrix?
I'll explain that to you. Is it you are going to do many questions under all these things we are covering?
Okay.
Yes, you will see how they ask you. It's a very, very important condition. I can tell you. This is a very, very important condition which you must take note of. You will see when we do questions of how to cover that thing. Yes. Now we are going to determinant, which is under chapter 2, of which you must know how to find the determinant for 2 by 2 and determinant for 3 by 3. Let's say we are given a matrix A. I'll start by finding the determinant of 2 by 2. So if we're given matrix A, B, C, and D, and we want to find the determinant, you must write on top here that we are now dealing with what is called the determinant. So the determinant is indicated by letter det, is det of A, of which if you want to find the det of A, this is how you do it. For 2 by 2, this does not apply to the 3 by 3. It only applies to the 2 by 2. You multiply the diagonals and then you subtract by the 9 diagonals, of which is going to be AD minus BC. That is how you calculate the what? The determinant. Are we all together?
Yeah.
And then from there, let me give an example by this matrix we have here. A matrix A, which is given by 2, 0, 0, 2, and we want to get the determinant of that. Determinant of A is going to be given by what? It's going to be 2 multiplied by 2, which is 4, minus 0 multiplied by 0, which is 0. Therefore, the determinant of this matrix is equal to what? It's equal to 4. Raw terms. Now, recall la condition in the amber, invertible, the invertible matrix. So matrix C, uba invertible, it's either 2 by 2 and 3 by 3. If determinant ya matrix equal na mini na 0.
Oh my gosh.
Rewrite determinant ya matrix ya na 0. Rivana zvichu zvinera zvimizori invertible matrix. Invertible matrix. So if determinant ya matrix ya na 0 rivana invertible matrix. Raw terms. This is the information about determinant of 2 by 2. Let me now do the determinant for 3 by 3. Determinant for 3 by 3, of which I'll give an example by a matrix A, B, C, D, E, F, G, H, I. So how do we find the determinant of 3 by 3? So this is how we find the determinant of 3 by 3. I believe you are all with me because I'm going to explain another important thing here. One of you is not here. Who is not here now? Let me check. Oh,
yeah, network
and you basis. Original ndikotota kuchedza zvine zvava zvauthogwe zvine ndandikotoda vatu vote vakamiting uri ndichistavichedza risava na problem ndizvauthogwa mamanda uri panowana determinant ya 3 by 3. It's not back. What's the problem? Okay, if you get in, I'll try to summarize it for you. But this is how we get the determinant of 3 by 3. We get it by doing this, that on the first column, we have first entry, second entry, and third entry. So now we hold the first entry. And then after holding the first entry, this first entry is going to hold the first row and the first column. If we hold A, the A is going to hold all the entries on the first row and all the entries on the what? On the first column, of which we are going to left with what? With a matrix E, F, H, I, of which you can see I'm not writing in terms of the square brackets. So the square brackets, you apply it on the matrix, but here we are no longer having the matrix, but we are now having the determinant. So it's the determinant of 2 by 2. This is how we write the determinant of 2 by 2. But this is another way for writing the what? The determinant of 2 by 2. You write this line, the straight line. They indicate the determinant of 2 by 2. Rewrite. Rewrite. Yeah.
ndogumapo vakuamba zori eyo fara line yayo yera vertical nayo yera horizontal zvamboredzo dzimwe dzi EFHI rito dzimwala risongopanga dzinakutete
dzikotiyo vangangomuha determinant. So determinant rinandira mberi dzine raimwanangadzo heiyo nova determinant ya 2 by 2 ine risumbedza determinant ngadzilines idzi dzine dzava straight. So ari iti determinant yava nadzicurl brackets kana square brackets ngamunandu wauri dzicurl brackets dziva dzikurepresenta matrix But it's a straight, so it's called represent a determinant. Yeah, 2 by 2 in a and the one of the debt matter in this case it's not proper to write the debt here. So you must write the determinant of EFHI. And you can see we take positive A, and then on the second one, it's a must that it must be a negative. So it's going to be negative B, and then we multiply by the determinant of the second matrix, of which the second matrix you are going to get by holding the first row and the middle column. So if we hold the first row and the middle column, we're going to get D, and then we get F, and then we get G here, and then we get I there. So that is the middle matrix. And then the last one, we hold the C. If we hold the C, it's going to get hold the first row and the first column. And if you hold the first row and the first column, we're going to be left with D, E, G, and H. So this is how you get the determinant of 3 by 3. So I believe from here, we can be able that.
Hey, network and man.
Yeah, naturally, eco-biases are man, and the coverage is a total man.
Abe, utobacheva tomoisa panda. Ka screen changa yoto imandundu boto imana palaka but avoko move avoketa chitu. Goso kufawa kwamba page vachisumba tivone chitu yoso kuima 50. Iyo ima mara maifiva kwamba ndikukapa.
All right, okay. Jembare, I think the best option is the way you recorded this lesson and then in the
Bondo. Hi, the rotovera soon. The rotovera feminine.
Recording.
Recording or a data mara. Let's continue.
Okay. Yeah. If
determinant. Yeah, 3 by 3. We're done with that one.
Yeah, I've done it, but now if it's also great, maybe tamsi mungawashu network ya murata jambo jari the magasho jari and the send a recording immediately after the lesson. We're going to record. Mara now our
3 by 2 or 3 by 3.
The 3 by 3. Yes. Then now because the explanatory video zaka YouTube was download this. So zaka YouTube bako yaba player video pala. So most much player video doga na URL in either www. So yeah, hapalaka www.panda. Wako yaba at the SS and then we enter. You don't but download that video. Rothems. Did you get that part for downloading the videos on YouTube? Okay, I know it's okay. Let me continue. You're gonna get the recording. I was explaining here of how we get the determinant of 3 by 3 matrix. So you hold the first row and the first column in order for you to get the first term, and then for the second term, you put the negative of the B, and you hold the first row and the second column. You're gonna get the second determinant. For the third one, you're gonna add the first row and the third column, which you're gonna get the third term, and then here you're gonna have the matrix. So now you're gonna multiply the determinant of the 2 by 2, of which you get by multiplying the diagonal separated by the 9 diagonal. So it's going to be EI minus HF minus B, and then here is DI minus FG, and then plus on the other side is going to be DH minus H. That is how we're supposed to get the determinant of 3 by 3, of which I'm going to quickly do an example so that you see how we apply these determinants that we have here. So let's say we have a matrix A, which is 1, 2, 3, 4, 5, 6, 7, 8, and then 9. And we want to obtain the determinant for that. So the determinant of A, we are going to obtain it by holding the first component there, or the first entry, of which if you hold the first entry, then the determinant that you're going to have, you're going to get it by holding the first row and the first column, and you'll be left with 5, 6, 8, and then 9. And then we subtract. The first one is positive, the second one is negative, the third one is positive, and the negative, positive, negative, positive. It alternates in that case. And I'll give you the reason why they alternate at later stage. So, but for now, just take it as that, like that is the formula. So, and then the second one is going to be -2, and you're going to hold the first row and the second column, which is going to give you 4, 6, 7, and then 9. And then the third one is going to be 3. You hold the first row and the last column, and you will be left with 4, 5, 7, and 8. So after having that, you are now left with multiplying the matrix, of which when you multiply, you multiply that.
One in a Rahul, the one is what 5, 6, 8, 9. That is.
Yeah.
You know, Richard that Panda Rahul, that 2. Lakini utaranga 4, 6, 7, 9, 8. Abadon chumezanya vuri babu zitisa babu ifarsani baikuku by yasaranga zibio zobdi.
So roll the 8 uti in a iko fara he row yote, and then you have fara na economy yote. So I was 4, 6, and then I 7 and 9. That is what is coming from there.
Oh.
Same thing now. For 3, you hold the
okay.
Yes, exactly. And from there, this multiplied by that is going to be 5, multiplied by 9 minus this is 8, multiplied by 6 minus 2. This is the determinant of 2 by 2, of which I believe you know how to deal with that. So this with that is 4 multiplied by 9 minus 6 multiplied by 7 plus 3 into 8. This multiplied by that is 4 multiplied by 8 minus 5 multiplied by 7. You just do this by calculator, you get the answer. You will now get the determinant of a 3 by 3, of which if the determinant is equal to 0, I told you what this means. If the determinant is equal to 0, you now have what is called what? The invertible matrix. But now I'm not saying this is going to give you a 0. So you must not get a 0. So that is very important for you to get. Of which I don't think it could be important for me to give you another information other than that that we have covered. We have covered 3 important things. The first, we have covered the symmetric matrix. The second, we have covered the determinant of 2 by 2. The third, we have covered the determinant of 3 by 3. Raw terms. Cover a topic guitar without talking about. So tomorrow, let me make sure you are all with me so that you get me right of what you're going to do tomorrow. Raw terms. Hello. Okay, network equalize. But now, tomorrow, Rikoyo Ukavara questions like assignment. We are going to do all the questions from the first one until, we're going to do the questions on the assignment from question number 1 up to the last question. I know we are going to cover some of the questions of which I did not teach you as yet, but most of the questions there is what I taught you already. So you must not have any problem with regard to that. So I'll try to explain how we're getting to the solutions of all those questions. So otherwise for today, I think we can stop here. Let's be hopeful that the network tomorrow is going to be strong. Yeah, Maranda Koskombronga, Gori network for today. Aristope happened on the cover of guitar is in the October, but when I was a revise, much of data, no, Aristotle for today.